Yancy! Today we're going to be talking about solving any type of equation for any variable. These equations can be famous ones historically speaking, or just random ones where you're trying to solve for any letter. And of course, things are going to be a lot easier if we pay attention to these pro tips here. First tip! Consider the order of operations you'd have to use when you plug in a value for the variable you're trying to work towards. Then, you can work backwards from that procedure to figure out what the variable equals. A lot of times, that's easier said than done. That's why we got more tips, Yancy! These next ones are good tips for solving in general, so watch what happens when we use them in the examples below. First, if you got multiple terms that have the same variable, you can always try factoring it out. Also, if you have a variable that's squared, try saving the square rooting for the end of the problem. Don't square root too soon, Yancy! You'll lock everything up in the radical! On the other hand, if your variable is under the square root, try isolating the radical first and then squaring both sides. Listen up, Yance! You can't access anything under the radical until you've eliminated it, so don't try and subtract the things under the radical before it's gone! I mean it, Yance. It's completely illegal! Finally, just know that there's no one way to do these problems. There's a lot of different types of equations out there that are going to require different steps to get to the answer. You can usually do them in whatever way you want, just pay attention to the algebra. That goes for these problems too, Yancy. Just because I do them one way doesn't mean it's the only way. If you got something you like better, then do it. I don't really care. Now let's quit yakking and get to work. Our first example is a equals b1 plus b2 over 2 all times h. If you recognize this, good for you. It's the trapezoid area formula. This time we're being asked to solve for b1. If you've never seen these little numbers down here before, the 1 and the 2 are called subscripts. They don't really mean anything, Yancy. You're not going to use them in the math. All they do is classify things as first, second, third, and so on. So in this case, B1 is the first base and B2 is the second base. Other than that, they don't really do anything. Now, like the first tip tells us, we're going to try and figure out what we'd have to do if we plugged in a value for B1. The first thing we'd have to do is add B2. Then we'd have to divide that answer by 2 and then multiply that answer by h. So let's get to it, Yance. First thing we gotta do is get rid of that h. We're gonna do that by dividing both sides by h. Don't worry that it's not something that we can actually evaluate. We're just gonna leave it as a over h. That's gonna leave us with b1 plus b2 over 2 on the right side. Now we gotta get rid of that 2 in the bottom, so we'll multiply both sides by 2. Keep in mind that 2 is the same as 2 over 1. I say that because it's going to make our answer on the left here a little easier in 2a over h. On the right hand side, we still have b1 plus b2. If we're trying to get b1 by itself, we just got to move that b2 over. So we'll minus it from both sides, and our final answer is 2a over h minus b2 equals b1. I don't think that one was too hard, Yance. Let's try another one to see what we can do. Our next example has a solvent for r when we have p equals 2 pi r plus 1/2 r times h. As it is, it's not immediately apparent what we should do first when we have a value to plug in for r. But if you were paying attention at the beginning, you might have an idea of what to do. Looking closer, you'll see that both terms have an r in common, both in 2 pi r and 1/2 r h. When your terms got something in common, factor it out. So we're going to have r times 2 pi plus 1/2 h. This might look a little bit more complicated than before, but the 2 pi plus 1/2 h is just going to be some random old number when you have a value for h already. That means that whatever it is that we get inside the parentheses is just going to be multiplied times r. How do you get rid of multiplication, Yance? Divide it away. So let's do that. Divide both sides by 2 pi plus 1/2 h. And if it seems weird to divide by something with a plus in it, that's okay. The parentheses help us recognize the fact that that's supposed to be one term. That cancels out on the right, And we're going to be left with an answer of p over 2 pi plus 1/2 h equals r. Now I'm not going to write the parentheses here, Yance, because technically we never needed them in the first place. It was really just to help us stay organized. So if you like them, keep them. I couldn't care less. Alright, Yance, I'm running out of time here. If you want more examples, move on to part 2.